Good morning. I tried to install Kubernetes.
No, sir. Actually, my account is right now suspended.
Okay, so try to create a Kubernetes cluster.
Sure.
So, 2 instances, but 2 CPUs are mandatory for master. So hence T2.micro may be not enough.
So once we create, yes, it not to it doesn't work in T2.micro, right? Sir?
Yes, only for master component.
So once we create that instance, so we need to remove that instantly once we have done with the practicals, right?
T2.medium you take.
Okay.
Okay, so now here, what are the components we have in the Kubernetes architecture? So here we have master and node. So master itself now we can call as control plane, and node we have previously it's called as minion or workers also we can call. Okay, so what are the master components?
API server,
API server,
Scheduler,
controller, and
controller, and
distributed key store value.
it's etcd. It's a distributed key
ETC.
value store,
Key
store
value store.
the information regarding the Kubernetes cluster. Okay, so then what are the node components?
Kubelet,
Kubelet,
Kube-Proxy,
Kube-Proxy, container runtime.
pods.
On top of that, we have the pods. On top of that, we have the pods. Okay. So what are the CLI tools we have?
kubectls.
The kubectl for bootstrapping. Kubeadm. It's a Kubeadm init, join. So these are the commands we'll use using a Kubeadm kind of thing. Okay. So then what is namespace? Virtual clusters we can create on Kubernetes using namespaces. We have multiple teams. The resources means CPU, memory, storage. So those other teams may use our resources more. So in order to avoid that one, if I have the multiple teams, then we are going to manage the by creating namespaces. If we have the multiple environments we have, okay, so within that scope only they can work. They can't come out of, say we have a very big undivided share is there. We can split that into walls and we can only within our flat we can reside. Others may reside in their space itself. Okay. So otherwise they may complain we went to their space, they came to our area. So like this kind of say here it's going to create a virtually a cluster, and we are going to allocate the resources to those by creating the. So when we are going to create the namespaces, we have multiple environments where the multiple users are and multiple teams are using the same cluster. Okay, multiple teams or multiple environments or multiple projects are using same cluster. Then for them we are going to allocate the resources. And for them we are going to allocate the resources by creating the namespaces. Okay, so then here by default, what are the namespaces we are getting is 4 namespaces we are getting. Okay, so can you tell me those names? By default, if you don't use any namespace, all your resources or workloads are going to default namespace. But it's not recommended in the real time to use default namespace. We can create our own namespace. Okay, so then Kubernetes will have a lot of internal etcd, those also running, lot of pods are running. Those all will use Kube system. Internal Kubernetes related parts all will use the namespaces Kube system. Okay, our own resources all by default will use
Kube system.
Default. If we create a resource, it uses the default. Internal Kubernetes related will use default. Okay, so Kube public to everyone if want to show, but we don't create in Kube public. If we have any special requirement, then we'll use Kube public or Kube node lease. But as of now, we are going to use default for our own resources, Kube system for. Okay, if you create a Kubernetes cluster, by default we are getting 4 namespaces. Can you tell me those 4 namespaces? What are the 4 namespaces we got?
Default.
Default,
Kube node lease.
Kube node lease, Kube public,
Kube public. And Kube
Kube
system.
system.
internal Kubernetes related one all will use.
Default.
No, internal Kubernetes related. It uses Kube system. Okay, if you create any resources, those will use default namespace. Is it fine?
Yes, sir.
Then you want to create any resource, kubectl. I'm going to create a like this. How many namespaces I have created?
3.
So what kubectl get namespace will do?
We can select a specific kubectl. Sir.
Yeah, kubectl get namespace will show you all the namespaces what we have. Are you able to understand?
Like an ls command, sir.
Come again?
Like an ls command.
Yeah, actually Docker PS will list all the images, the containers, Docker images will list, say here, what are the namespaces we have? We can see using
kubectl get namespace.
kubectl get namespace. But instead of creating the namespace through command, okay, we'll create through YAML file. Okay, whatever the YAML file you have, okay, say give, say in this scenario, my namespace dot YAML assume or YML. Like this will keep kubectl create -f any of the resource we can keep in the form of YAML format. Then what is the command here? From the YAML, if you want to create the resources, what is the command?
kubectl create -f
Yeah,
namespace
otherwise,
and
if for the second time onwards, if you want to do any modifications, kubectl apply -f. So like this, we are going to create it.
if you make any modification, right?
Even for the first time also, we can use it.
Okay. Instead of using create
But-
command, we can use apply.
Yeah. But normally want to use for the first time, we need to use create. If any changes has been done,
Then we can use apply command.
yeah. But even for the first time also, we can use
Apply.
apply. Okay. Any doubts on this? So now, how that YAML file looks like, we'll discuss. So get namespaces will show all these namespaces what we have. So this is the YAML format. -f means file. So here, what is the namespace you want? You can specify here. So in this, I want the namespace is. So we have a lot of advantages instead of using the command line, using the YAML files. Do you understand this YAML file? So what is the kind of resource? What is the kind of resource?
Namespace.
Namespace. Then so here itself in the YAML itself, you want to delete a namespace, assume. You want to delete a namespace, otherwise kubectl. If you use that YAML file, in that YAML file, we have the namespace, right? That namespace would be deleted. Is it fine?
Yes.
Okay, so like this, we can delete the namespaces also. Again, the pod or deployments, all these also. Okay, so we can use the YAML files itself. Now try to understand. So now I'm going to create a pod here. Okay, so here normally Docker run will use, right? Here kubectl run nginx -- image nginx we given. If I don't give the namespace, what happens? If I run this command, what happens? Kubectl run nginx -- image equal to nginx. If I run this command, what happens?
It just downloads the Nginx image.
No. It will create a pod also. Okay, but
It will ask us to specify or create the
it will create
namespace.
in the default namespace.
Okay, so it will take the default namespace.
Yeah, it will create the default namespace. But here what we are doing, -- namespace. Say, I want to create this in then in the ITCM dev, it's going to create that
Namespace.
no resource. That pod is getting created in that ITCM dev namespace. Is it fine?
So ITCM-dev is a namespace, sir?
Is the namespace previously we created here, right? ITCM dev, prod, QA, like this for 3 environments, I created 3 namespaces.
Okay. Understood.
Okay. If I want to QA you create ITCM hyphen QA, they will use. Is it fine? Then
Yes, sir.
if I use the command kubectl get pods, it won't display. Why? It only displays from default namespace. Okay, which of the parts are running in my internal in Kube system? If I want to get it, I need to use that command. ITCM dev if you want. Okay, so by default, even if you retrieve the kubectl get parts, only retrieves from default itself. So that is the reason we need to specify our own parts also. Sorry, our own namespaces also we need to specify. Any doubts on this?
No, sir.
The parts are the smallest deployable units. Okay, say after pod, it would be created internally container itself. Okay, a pod like is an encapsulation of one or more containers, their storage, shared storage, and their network resources we can run. Okay, so by default, we may have one pod with one container or one pod with multiple containers also. But we don't deal with the individual parts itself. We are going to manage. Deployments or daemon sets or stateful sets itself. Okay, first we'll understand the pod, then we'll go for those. The smallest managed resource is pod itself. After that, Docker will manage it as a container. So here we have a sample. If I give the YAML file as YAML assume, in this I have given this code. Okay, so here previously the kind is the namespace we created. Here this YAML will create a pod. And the first one is the API version we need to specify. Okay, that is common. Then kind, most of the meta information. Then in the specifications, we are going to give the container. If we have multiple containers, then even we can specify the multiple containers also. Okay, so how we can create this command? kubectl. Otherwise kubectl. Is it fine? In the same way, you can write a tomcat kind of command also. Okay, for tomcat also try to write YAML file. What you need to do? That name you can change as tomcat and the image is
Tomcat colon latest or 9 or whatever the version we require.
The container port maybe for tomcat is
8080.
8080. Then you can create a. And while creating, we need to specify one more thing. So one more we need to specify in the real time. What is that?
Volumes.
As of now, not volume. We need to attach the namespace also. Otherwise, it uses default namespace. In the real time, which is the namespace, which has the namespace has been attached to you, only use that namespace only. Instead of doing this through YAML file, even we can create through command also. So I given here nginx-pod. So here also you want that nginx-pod that you can specify. When image equal to nginx, you wanted any specific tag. If I use only nginx, it uses the latest one. You want a specific version, then specify that tag. Okay, so both are same, but which is recommended?
YAML files.
YAML file is recommended. So here in this pod, how many containers are there? Only one container. But in Kubernetes, we may have two possibilities. One is pod that can run a single container or pod that can run
multiple containers.
Multiple containers. That means in the single file will have a
multiple containers.
Multiple containers. So how that YAML file will look, we will see. So here in the container specification, we are going to specify multiple images. Okay, so in the container specification, what they did, they kept two containers. That means this pod contains
two containers.
Okay, but in the previous example, a pod can contain one container. Otherwise, a pod can contain. If both the pods want to use the same storage and same network, then go for multi-container pod. Otherwise, it's recommended to go for single container. Can you tell me in which scenario we'll go for multi-container pod? If both the containers want to share the same network and same volume, if you have any special requirements like that, then only go for
multiple containers.
Multiple containers. Okay, but we don't deal with the We don't deal with the pods. Okay, we will deal with the pod. What are the pod controllers we have? Deployment, daemon set, stateful set. So what are the resources we have here? Deployment, daemon set,
Stateful set.
and stateful set. Okay. So here, if you want to create 100 replicas of the pod, then you don't create 100 pods. Create a deployment and specify 100 replicas, then 100 pods would be created. Okay, so we don't deal with
Pods.
individual
Pods.
pods. Okay, the higher level of object is deployment. So when we specify the deployment, the declarative updates for pod and replica sets. If you want to update or any changes, multiple pods, all those can be deployed as the deployment. The higher level of object is deployment. Okay, so now for the same Nginx itself, I'm going to create a deployment. So here through the YAML file. So if I specify this as Nginx deployment, then what is the command? kubectl apply -f, that YAML file we need to specify. Okay, this, can you tell me how many parts are getting created with this? With this, how many parts are getting created?
3, sir.
3 parts are getting created. All the same specifications they will use. Okay, if I run, say, assume this this one Nginx -deployment dot YAML, I given the name here. Apply -f. If I run this command and --, namespace also I'll specify. Okay, then the above command will create one deployment, one replica set. What is that replica set? We'll discuss. And how many parts?
3 parts.
3 parts. Okay, so 3 parts are getting created. Okay, then kubectl get deployments Which command I need to use? First one or second one?
Second one, sir.
Second one, because deployments will show only from
On the deployment, sir.
only from the default namespace. What is that? Get RS.
Resources, namespace.
No.
Replica set, sir.
Replica set. How many replica sets would be created?
3.
3.
3. Not 3. Not 3. 1 replica set.
Yes, sir.
one deployment, one replica set, and 3 pods are getting created. Is it fine? So what is the purpose of replica set is? Always say if any of the pod is deleted, okay, then replica set will tell to scheduler or to API server it's not running 3 pods. Then scheduler will schedule a new pod. So what is the advantage of replica set? 24/7, it would be keep on monitoring
Pods.
that minimum 3 pods are running or not. If it is not running, then that will tell to API server, then scheduler will schedule that minimum 3 pods okay, on the nodes. You no need to monitor 24/7 whether minimum that number of pods are running or not. Who is responsible for that?
Replica set.
Replica set. Are we creating replica set directly? Are we creating replica set directly?
Yes.
We are not creating replica set directly. When we create the deployment itself, automatically it's getting created.
Okay.
Okay. The higher level of object is replica set or deployment?
Deployment.
Deployment is the higher level of object. That itself is automatically creating
Replicas.
replica set. Okay, we don't deal with directly with the replica set. And what is the purpose of replica set?
It monitors the pods, number of pods we have.
Number of pods are running or not. If that is not running,
It will notify to the scheduler, and scheduler will give another pod
another pod is getting created.
created.
Okay. A deployment in also in the pod specification, if it is having multiple containers, we can specify. Okay. So now here if I use kubectl get deployments, okay, so three are available. Okay, 3 pods, but as of now it's created only 3. Okay, then kubectl get rs will show us replica set. And these are the pods. How many pods are getting created?
3.
3 pods created. Internally in the Docker, how many containers should be running? If you have 1 container in 1 pod, 3 containers should be running. If you have 2 containers in 1 pod,
6 containers.
6 containers should be running. So now, what is the image we use this? In this, we use Nginx.
One 1.14.2.
That assume tomorrow we got a new image. Set image. Instead of doing this command in the YAML form itself, we want to see what are the steps we need to do. In the YAML itself, we want to do what we need to do here. Go to that image, change to 1.16.1. Then we need to run one command. Create or apply?
Apply, sir.
Only apply will work because that resource already created. For the first time, we can use either create or
Apply.
apply, but you want to edit. But some of the people are asking instead of YAML file, how we can change through command. Then what is the command?
kubectl apply -f.
No. Kubectl set image deployment. This Nginx image I'm changing to 1.16.1. Okay, I'm setting that image to this. Like this in the command line also I can do. But I recommend to do through
YAML files.
YAML file. You want to add more replicas also, we can perform. And get will show only the basic details. Say in the Docker, we have inspect one command. Yet describe will show us more details regarding that. If you want to troubleshoot, definitely go for describe command itself. You want to troubleshoot, then better to go for describe command itself. It shows a lot of information regarding the deployment, which we need to use for troubleshooting purpose. So it shows like all these details, it shows, and whether it's running all the events also, it shows. If any updated rollout history, we can check to which version it moved. These all will discuss, but these all will use the Helm charts. I'll explain in the Helm charts how we can do the updates. Okay, this is more important. So one way what we can do is in the YAML file, we have the replicas, right? 3 replicas that you can change to 10 and the kubectl apply -f that YAML file we can specify. Otherwise, if you want to scale up the parts based on the command, then what is the command? You want to scale up the parts from 3 to 10. So what is the command we can use here?
kubectl scale deployment.
Scale deployment. What is that Nginx deployment is?
That is the image.
No. That is our deployment name.
Oh, yes, that YAML file, right?
No. In this YAML file, this is the name of the deployment.
And sir, you have even told us that to mention the namespace, right?
But what is the name? Whatever, it's nowhere related to that. That is the just name of YAML file.
Okay.
So what is the name here we have given is more important.
Understood.
That name we are going to give the deployment / Nginx deployment and scaling to replicas is
10
replicas. Otherwise, what we can do is in the YAML file itself, here in the replicas, you can specify.
You can replace 3 by 10.
Yeah, 10 replicas. Then kubectl apply
-f.
Nginx deployment at
YAML file name.
Yeah. So like this, we can create it. Any doubts? And here we have one horizontal pod autoscaler. I'll explain later again, but try to understand. This will scale up from 10 to 15. Okay, just like in AWS, we enable autoscaling, right?
Yes.
Here we are enabling HPA. HPA stands for horizontal pod autoscaler. Horizontal pod autoscaler. So what is the advantage with that?
It can scale automatically without.
Yeah, without when in this example, what is the condition they used?
Minimum 10 pods to maximum 10, 15.
What is the condition they use? If the CPU reaches,
80%. Sorry.
if the CPU reaches
80.
80% of usage.
80%, then they're going to
Maximize the pods to 15.
maximize the pods. Okay. What is the maximum number of pods we can get it in this?
15.
15. So if I specify 10, that is fixed 10 is. But what is the advantage of HPA? What is the advantage of HPA?
It will auto scale, sir.
Automatically. HPA stands for
Horizontal auto
horizontal
scaling deployment.
pod autoscaler. Horizontally pod.
Auto
Autoscaler.
scale.
Okay, so in this they use the CPU of that. If 10 CPUs all reaches 80%, then they will scale up to
15.
15. 11 maybe it created, even that also reaches 80% of CPU. So like this, we can auto scale also. Get deployment or get deployments also same command. Then what is the replica set? At any point of time, need to maintain a stable set of replicas. Okay, so we can create a replica set also, but there is no use. Directly don't create a replica set. Create a deployment itself.
Deployment.
So now here we can create a replica set also. So now replica set ensures that specified number of parts or replicas are running at any point of given time. But deployment is a higher level of concept that manages replica sets and provides declarative updates for. Therefore, Kubernetes is recommended to use the deployments instead of directly using. We can't update a replica set parts, but whereas deployment can be updated, rollback, all these are not possible with if I create the resources. Even if I create a replica set also, it may create.
Deployment.
No. It may create, what is the lower level of objects of replica set?
Pods.
Pods.
Pods may be created, but updating, rollbacks, all those are not possible with replica set. Those are possible only with
Deployments.
deployment. That is the reason we are not directly creating.
Replica sets.
So here, this is the YAML file. It's 99%. It's same like a deployment itself. But here the kind is
Replica set.
replica set. But why we are not directly creating a replica set? We are creating deployments because
I'm not like dealing with directly with the replica.
if you want to roll back, okay, scale up. Scale up can be done again using the replicas if you specify 5. Updates, rollbacks are not possible at
Replica set.
With the replica set.
we may go for replicas that directly is I don't want to update in the future. That's it. It's fixed. Then you can create replica set. But not a best practice. Create always a deployment itself. Are you able to understand?
Yes, okay.
And we don't deal with individual parts also.
We deal with the pod controllers.
Yeah, that is the deployment as of now.
Okay.
We have a slight difference between deployment, daemon set, and stateful sets. Those we'll discuss. Okay, so then we'll go for a daemon set. What is the concept of daemon set is? In deployment, if I give 10 replicas, and assume I have 5 nodes, then how scheduler can work to schedule is there is no guarantee in all the 5 nodes, those pods would be running. Are you able to understand that? There is no guarantee in all the nodes, the pods would be running. How it would be running? So maybe in one node, 3 pods may be running. In one node, 2. In one node, only 1. In one node, again, maybe 3. But in one node, it's not running. Who is the decision maker here?
Daemon set.
No. In the master, we have one component on which node the parts need to run, how many it need to run is going to be decided by scheduler. But I have my requirement. What is my requirement is on each and every node. If I have 10 nodes in the deployment, if I specify 10 replicas, it won't guarantee on each and every node one pod is running. But I have a requirement, okay, my monitoring agent or storage agent or like maybe networking kind of plugins. I don't want to run, okay, multiple on one node. What is my requirement is on each and every node, one pod should be running. If you have this kind of requirement, the best resource what we need to create is
daemon set.
Daemon set. If I have like a 10 nodes, how many parts would be created?
10 pods.
10 parts. If I have 20,
20 pods.
in that if I create a deployment, there is no guarantee in each and every node.
Pods are running.
One pod will run. When some nodes may run more pods, in some nodes it may be skipped also. But I don't want like that. In each and every node,
Pods should be running.
one pod should be running. So for this purpose, we are going for
Daemon set.
daemon set. For this purpose, we are going to create the
Daemon set.
daemon set. Okay, so can you tell me some examples here? We can use the running edge storage daemon on each and every node it need to run. Otherwise, log collection, because I want logs from every. If a log collection agent is not running on one node, what happens? From that node, I can't get the. From that node, I can't get the logs. Okay, say if one node monitoring agent is not running,
We can't monitor the node. You can't get the logs.
so that is the reason it's recommended to go for daemon set. Then daemon set will make sure if
To get information from every.
the cluster automatically these parts would be running. You understand that? You no need to worry to deploy automatically. That part would be running in the new nodes also, because it's a daemon set. And is it running 2 or more replicas or only one on one pod? Sorry, one pod on one node. So one is enough for us on each and every node. Any doubts? So now here we have maybe monitoring kind of thing, Prometheus or otherwise Logstash, CNIs. So these all we are going to run as daemon sets. Those are for the cluster monitoring, cluster management kind of tools, not our application deployments. Not our application deployments. So here we'll go for a sample YAML script. So here the kind of the resources daemon set. So this is an elastic search maybe for the Logstash we can use. Okay. So here try to understand this one. We given the image. So what is the meaning of resources is if we create a T2.micro, how much memory and how much CPU will get? One CPU, one. Okay. So like this itself, you can allocate
resources.
CPU and memory. Okay. What is the difference between limits and request? Limits versus request.
Like if the limits, we are setting the limits
Yeah.
for the memory, and once that limit is crossed, then we are requesting the resources to expand.
This is the like minimum. Limits is the maximum.
Okay.
Limits is the maximum kind of thing.
So it will go up to CPU 100 M, right? And memory 200 MB.
Yeah, memory 200 MB. Okay, so here in the limits you can give like this. We can allocate the resources. Just like in the CPU, based on the micro like this, we are getting the maximum cap. Here we can specify the minimum and maximum also. Limits also we can specify. And here we no need to specify in the daemon sets how many replicas we want. Because how many number of nodes we have, that many
number of pods.
That many would be running. Okay.
So in the daemon set, we have one node per one pod, right, Srikanth?
In your cluster, if you have 100 nodes, 100 pods would be created.
Each node, there will be one pod.
One pod.
Okay, so for each node, there will be no like 10 pods or 20 pods.
No. That is the challenge with the replica set we'll get. But I want only one pod in each and every node. It should be running for me.
Okay, just for one pod, for one node, one pod in daemon set.
For most of the monitoring or monitoring management kind of thing, networking, storage drivers, in each and everything, it should be running mandatory for us.
Okay. Yeah.
So those kind of things will deploy as a daemon set. Our production application microservices will deploy using deployments or stateful sets. Okay, so tomorrow we'll discuss stateful sets. But for that, we need to go for PV and PVC. Then we require storage also. That's we'll discuss in the tomorrow class. Okay, download this. and try to create the Kubernetes cluster. If you're not able to do, at least create an EKS cluster in AWS EKS.
So create the Kubernetes cluster in Ubuntu.
Yeah, take two Ubuntu instance, one mission master, one mission node.
Worker. Okay, node.
Yeah.
Okay.
Otherwise, try to create an EKS cluster. Even through Terraform also, we can create the EKS cluster.
Okay.
Okay.
Yes.